Hello, everybody, and more specifically, my professor and my parents, because you're most likely going to be the only ones who see this. And that's okay, I'm okay with that. This is my presentation about the geological history of Iceland. So, Iceland, and where is it? The plant plates and ridges. So, before we start, I do apologize that I'm going to be mispronouncing a lot of words. I am not really not skilled in pronunciation. So that's why if you don't know what I'm saying, you can just read the presentation, and I do apologize ahead of time. So Iceland is currently located on two tectonic plates, the Eurasian and the North American plate. Both plates are currently moving together over a hotspot going northwest. And going over a hotspot is giving perfect conditions for volcanic eruptions. So, sitting on the mid-Atlantic ridge, of course, Iceland is home to volcanic eruptions and earthquakes. The ridge isn't just home to Iceland, but instead it stretches from the Arctic Ocean and goes all the way down to like the southernmost area of Africa, which is pretty long. Yearly, it separates about 2.5 centimeters, and Iceland's one of the few places where you can actually see the tectonic plates and the ridge. And so if you don't want to travel like way deep into the ocean, you can just, spend a visa to go there and see it. The coastlines and oceans. So right now, the coastline of Iceland stretches about 3,000 miles. And since it's always extending because of volcanic activity, that's why I said currently. This may seem pretty large, but keep in mind it's like going from like all the way around. But Iceland's also located about 186 miles away from Greenland, which you can take a ferry there. Off the shoreline, Iceland is located on the North Atlantic Ocean, and the North Atlantic Ocean is the second largest, and is responsible for weather patterns and for migrating animals like dolphins. So, the geological history. What is Iceland made out of? It's made out of rock, obviously, but what kind? It's made out of balsanic rock, and again, ahead of time, I do apologize for mispronouncing. I'm just not good at that. It's one of my flaws, and I like my flaws. So, the island is sectioned off into three different balsanic rocks: the Tertiary and the Quaternary and the Hyaloclast. I'm going to get points off for this, which is in the central, southwest, and the east area. The reason why Iceland is made out of balsa is because of the high volcanic activity and when it's being formed. So these rocks are formed under magma, and when magma begins to cool, it begins to harden and like really harden, kind of like bedrock in Minecraft. It's super hard. And one of the really interesting things about balsa rock is it forms in a hexagon shape, and that's just one of the many amazing phenomena that Earth does, where it's just like everything's like tied to math in some way. It's geological, and it's beautiful. So Iceland's formations in the timeline. The oldest dated formation is the Tertiary granite, and these rocks were formed about 13 million years ago. That's a long time. And they were formed under magma and then slowly cooled. During the Ice Age, about 3 million years ago, volcanic eruptions began to melt holes in the ice, and it spewed a bunch of sand and water and glass. And these created the shorelines and the mountainous peaks that we see today. I'm going to move my little face real quick. All right. In the modern lava era and currently present, it began about 10,000 years ago, and currently there are 130 volcanoes, with about 30 still active. And you can see some of those active volcanoes at the Thingvellir Natural Park. Not sponsored. I'm going to move my face again. So, how it works. In the past, in theory, Iceland's creation was when hot magma rose from the core into the crust. and it was traveling at about 1,800 miles from the core. Again, that's a long ways. And the magma was subjected to pressure changes. And you would think that because it was constantly under a decreased amount of pressure and being cooled, it would harden. But no, because it was in a decreased atmosphere, it became still liquid, I'm just going to call it. And the mantle plume would get to the crust and create hotspots in the ocean and stuff. So this little section is explaining the images that we're going to see in the next slide, because I thought, like, if I had my images together on one side and it's kind of tiny, you wouldn't be able to really see what I'm trying to explain or see like the beauty of like the volcanic rock. So again, I'm going to move my little face so you can see the bottom, because I can't see the bottom. About 60 million years ago, the mantle plume began to leak magma to the surface. As time and pressure progressed, the separation of two tectonic plates caused the mid-Atlantic ridge to form, because again, it's separating, it's causing all that pressure to go through, again, separation, which created Iceland. The image in the next slide demonstrates the releasing of the mantle plume to the surface, and in the second image, again on the next slide, when the plume separates through the crust, it creates hot spots in the earth, or depicted in the image, a volcano. Move my face again. And I did label all of my images so you can correlate, but this is the volcanic rock. And I wanted to choose this one because this was in the thing of our national park, and you can kind of see how they just form in a hexagon-like shape, and it's all geological instead of round and misfigured. And in this image, it demonstrates the core and the mantle around it, and the mantle plume kind of going up, starting to rise off the core. And the image below demonstrates when the plume reaches the edge of the crust and it slowly starts penetrating through it, it creates a hot spot, because like when the magma reaches through, it creates like materials all around it, and then you get a volcano. So geological mechanisms, and this slide is separated into 3 different parts: the separation, hotspots, and volcanic rock. Iceland was created on 2 neighboring tectonic plates, again the North American and the Eurasian plate. 20 million years ago, mantle plume fed from underneath the water in an underwater volcano, which then erupted along the mid-Atlantic ridge, and materials spewed out and created. Powerful pressures and forces caused the 2 plates to begin separating. The separation rate is about 3 centimeters or 2.5 centimeters above. And Iceland is the only place in the world, again, where you can see these tectonic plates, and I think that's so cool. That's why I said it twice. Iceland has the most active volcanoes on a single island, and not only are there underwater hotspots that emerge, that are emerging mantle plumes, Iceland separating plates has called subduction zones, which is when, pretend this is a plate and there's another plate kind of pushing along and it goes right underneath it, and that creates so much friction and magma and just goodies. So the subduction zones have caused earthquakes and fuels for volcanoes, and that's why in the image above about the hotspots, you can see where all of the active volcanoes are, where the tectonic plates are kind of separating, where there's subduction zones causing friction and magma to happen, and it's so cool. So the lateral rift systems occurred about 7 million years ago. When the lateral rift was active, it was situated at then Faroe Islands, again, pronunciation, I'm not good at it, and the eastern Greenland, where it deposited volcanic materials, while also forming like submarine ridges, which underneath the water, this kind of stuff. in the image below. In modern day, it is located across Snæfell Peninsula and the Hana Bay, which is also connected to the Mid-Atlantic Ridge. So, what is currently happening to Iceland today? Well, Iceland's falling apart, literally. It's nothing, not like political or something like that. No, I'm saying the island itself is breaking into 3 parts. And this is causing like mass earthquakes and volcanic eruptions and panic. So the reason why it's separating is because the east, west, and the North American and Eurasian plates are all shifting apart. And even though Iceland is shifting, the separation of land masses will never occur because of the high volcanic eruption. It's when a landmass separates, a volcano generally erupts and it fills in the cracks, kind of like glue. And the current most active volcano is the Grimsvötn, a very cool Finnish name. But it's it currently erupts every 14 years and it's one of the most active volcanoes. Iceland's unique volcanic activity has positive aspects when it comes to tourism. However, the climate change is a new addressed issue. The severity of each eruption has resulted in Iceland's glacier melting. And the glacier's melting isn't a form of like higher sea levels, but instead what happens is it uncovers a bunch of these, because like I said above, the volcanoes typically erupt underneath under like a pretty thick layer of ice, and if these layers of ice are melting, the ice isn't going to act like a shield anymore with all the magma and ash spewing out. And I'm going to say it was about a couple, I can't remember the year, but a while ago, Iceland had a pretty massive eruption that caused all of this volcanic ash and spew to go into the atmosphere, and it devastated like their crops and their wildlife and the ecosystem, like the climate ecosystem. And that's the threat that they're currently facing today. So despite new land formations being uncovered with each glacier melt, an increase in volcanic activity is expected. Scientists predict that it'll take about 100 to 200 years until the ice has completely melted significantly. And that's an issue. We can't really do anything about it, but all we can do is really prepare for it. But in this image right here, I have demonstrated a volcano erupting, and there's all these people just sitting around the magma like, what are you doing? And I thought that it was a pretty cool image to show, because it shows the icy land and the glacier land of Iceland, and then it's just a massive active volcano just spewing out magma. So that's the end of my presentation, and thank you so much for listening and for tolerating my my mispronunciation and my silliness, because right now I'm so nervous and I'm trying really hard not to show it. But if you have any questions, please leave a comment down below, or if you're my professor, you can send me an email, and I will either redo this presentation or it'll be really good. All right, thank you so much. I hope you have a wonderful evening, and adios.